Yo, what up? Welcome to Made by Ozzy. I'm Ozzy, and it's been a few months since my last video. I do apologize for the delay, but I am back to try and spread the knowledge so everyone knows how to mine Bitcoin. So this video was actually supposed to be going over the Stratum protocol. How does our mining software, the Python script we wrote in the last video, how does it talk to a mining pool running a Bitcoin node? So since I made that video, I've just learned that they actually released Stratum version 2. So they've upgraded from Stratum version 1, which is what I knew and what I've written software for, to Stratum version 2. It's supposed to increase security. It's supposed to lower the amount of data that needs to go back and forth. And so I think it's important that I actually learn what it is before I can make a video showing everyone how to use it. I'm not going to teach anyone Python 2, right? You got to move on to newer things. Python is Python 3 now. Stratum is going to be Stratum version 2. And this actually coincides with another problem that I was anticipating with trying to, have a Python script to mine and actually connect to a mining pool. In that there's no way that a CPU running this Python script would ever actually be able to generate enough hash power to actually get some shares from any real mining pool. So what I'm gonna do is I want to make my own Bitcoin testnet mining pool, and I'm going to add it to my Made by Ozzy website. And we can mine some testnet here, and that way for sure, when we write some software to talk to a mining pool, I can know for sure that you'll get some feedback knowing that it's actually working. So in the meantime, while I'm working on that, I have completely redone my Made by Ozzy website. It's all with the Django backend, and I added this neat little proof of work chain that anyone can add to. It's like a little test bench you can wrap your head around proof of work. So let me show you what that is. Let's get started. The website used to be totally WordPress, so I totally redid it with the Django backend and mocked up all the HTML. And I tried to keep all the same information, like the overview of how the FPGA miner would work and like the mining details from crypto. And I wanted to host a Bitcoin white paper as well, because screw Craig, right? Doing it in Django lets me add some neat functionality, like this general proof of work chain. So I got this idea from watching this MIT OpenCourseWare lecture, and this whole series is really great. If you really want to learn blockchain technology, then I recommend watching this whole series. And I'm going to put my own video up on this side as soon as I'm actually done with it. But the general idea of this is it's just a general proof of work chain, which means that anyone is allowed to add any message as long as they submit it in this form, where they have the height of the chain plus the hash of the previous block plus any message you want plus a nonce, where that if you hash all of this data together, it meets this target difficulty, which just follows the same difficulty calculation as Bitcoin. It's just a fun little test bench, sort of the same thing as what Bitcoin mining is, but sort of low stakes. There's no Bitcoin on the line here. And I went ahead and started it with my own Genesis block. Notice there's no previous hash. And, it's not every day you get to do your own Genesis block. So the message I chose to insert here is Kirsty, the best of wives and best of women. Kirsty is my wife's name. I let the romantic out in me a little bit. Sue me. But now she's at the top of my blockchain. Then I have a few other little test messages, buy Bitcoin, and of course mandatory, and then a noble spirit in Biggins, the smallest man for any Simpsons fans. And then I just added hello nurse a couple times because I usually like using this instead of hello world, Animaniacs. The important thing to notice here is all of them start with 6 leading zeros. So if you actually were to take the height of this, so 3, plus the previous hash, which is just the current hash of the last block. Notice it's a bunch of zeros and then E0E, E0E. Then you add this message, a noble spirit in Biggins the smallest man, and then this nonce, it'll produce this hash, which has 6 leading zeros. So that's the requirement to get onto this chain, 6 leading zeros. 6 leading zeros isn't too bad. That'll take like a few minutes on a modern computer. So how do you actually do this? You have to send a GET request to this API to get data like this, and then you have to construct a message like in this format, hash it, find an appropriate nonce, and then submit your nonce and message back to this API. So let's build a little script to do exactly that. All right, I got PyCharm open, and this is the last file we wrote in the last video where we actually found a nonce for a block, and we actually mined a block. So let's make a new file, new Python file, and let's name it add block.py. And first things first, I know I'm going to want to copy all of the same imports. Okay, so first thing we're going to need is we're going to need the difficulty that we're trying to meet. So we know it is this value. So I'm going to copy and paste that. And so I know my bits is equal to that. But I don't want that. I actually want to be able to convert it into a 32 byte number. So we worked that out in the last one, so I'm just going to go ahead and copy that exact same code from that script we worked out in the last episode. And I need to define bits not as a string, but I actually need to define it as a hexadecimal number. Okay, except I don't actually need this print, I don't have that. So what's the next step? I need to actually query this URL, so let's go ahead and copy that line. And then to query a URL, I need to import another library, import requests. Let's see, okay. It looks like I need to have PyCharm install that. Okay, requests installed, so let's go ahead and query it. Response equals requests.get, and to supply it that URL, okay. And then let's print what it reads back to us, response.text, so we can actually see the text sent back. And we should see something that looks something like this, a JSON string with a field for height and a field for hash. So let's go ahead and run this here. So save and then run. All right, great. Yeah, look, height 5 and hash is this bunch of zeros, and then 60F, which should be the first block there, 60F. Great. Okay, that's JSON. So this is a JSON response. So go ahead and give that a variable, JSON string equals, just go ahead and grab that. And in order to actually turn that into something I could use, I'm going to import another library, JSON, and then I want to turn this into a Python dictionary, so I'm just going to call that block, and I'm going to call the loads function, json.loads, and you give it that variable, JSON string. And now what I actually want out of that is these fields, height and hash, because I'm going to use them to construct my message of the form this, height, hash, message, nonce. So let's get the height. Get data from last block, and height is going to be block with the field height, because now it's a Python dictionary. But I'm actually going to add 1, right? Because this gives me the last block's height. I need to increment it by 1. And then I also need the previous hash, and that's going to equal the hash that gave me. So block hash. Okay, that gives us our height and our previous hash, and we're going to need a message. So I'm going to define that up here so it's easy to change for y'all doing this at home. And this message can be anything you want, so it could even be something like my Twitter profile. So go ahead and copy that. Go ahead and add it right there. Okay, so now we're ready to start looking for a nonce. And I'm just going to go ahead and copy a lot of the logic that we worked out last time here with this starting nonce. And so I'm just going to copy this exact same code and paste it in here and then format it for what I need. So what I need to change is the message I'm actually hashing. So it's not going to be the Bitcoin standard stuff. I'm just going to put in my own, which is height, hash, message, and nonce. So I'll just replace version with height here. Previous hash is just a different spelling here, and I only have the 1. And then I need message and nonce. I already have nonce there, but I need to replace this one here with message. And it's similar to this because I'm going to have to use the codex library instead of the struct library because it is a string. So it's just going to be codex.encode, because I'm going from just raw string, message. And okay, what else do I need to fix? So here's the first hash. It's going to hash the header once, and then it's going to hash it again because I'm just going to follow whatever Bitcoin does. No reason to change it. Then reverse it again, just what Bitcoin does. Here's the timing. This is why I wanted to copy everything so I could have the timing. Okay, and here it is, searching or checking if it actually is less than the correct difficulty. And do I have different bytes? Yes, it is. It's up there. Okay, so this should work. Okay, so little adjustments. I'm going to slow down. It's not going to print so often, and I'm going to start nonce at 0. Okay, but when it finds the nonce, what do I actually want to do? I want to send a post, per what this says. I need to send a post with this data, nonce and message. So let's just construct a dictionary. Payload equals, and it's going to be fields nonce, supply to nonce, and field message, supply to message. Great, that should do it, and I should just be able to use the requests library. Let me get the response so we could actually see what it says. Response equals requests.post, give it the URL, and specify that data is this payload dictionary that we constructed. And then let's print what it says back to us to see if it worked or not. Okay, And one last thing I want to add before we try printing is I actually want to see, or try running this, is I want to see how long it takes. So I'm just going to copy this code here and just print this. Print elapsed time seconds and print time diff. All right. Okay, and this is ready to run, so let's run it. And here we go. Okay, it's hashing away. It's getting something like, oh, this isn't half bad. 122 kilohashes per second. My computer's doing pretty good right now. So I'm just gonna let this run for a while and then show you guys how long it took. Okay, it took something like only like 45 seconds. That's actually not half bad. I tried a few others and it took something like 2 minutes. So 45 seconds. I must have gotten a little lucky. So what that means is I actually, if I refresh the page here, I should see, yeah, check it out. It got added to the chain. The previous hash was this block's hash. There's a bunch of zeros and 60F. And this new block has this hash. So great, we added to a proof of work chain. Okay, so that's not mining Bitcoin, right? But it is a proof of work chain. It's a blockchain for all intents and purposes. You're not gonna get any coins for adding to it, but hey, it's a neat little exercise, you know. And if you want to have some fun, really wrap your head, just write some test software. Go ahead and add. You could add any message you want. You could put your LinkedIn on there. You want to prove that you've actually tried to do. This is a proof of work. You could prove to a prospective employer, look, I actually wrote a script, I wrote some software that did proof of work, I added my name to a blockchain, and there's a website, madebyozzy.com, and you could prove it. So make sure you hit like on this video and subscribe to the channel. It helps me to grow the channel. And if you run the script, then let me know how long it took. Why don't you comment down below? It took me 1 minute. It took me 5 minutes if you're real unlucky, So all the code we wrote up today is up on the GitHub. So go sync up with it, and I will see you guys in the next video.